Okay, here we go. Another problem. This is the same drawing as before, but the values are different, obviously, and what we are asked to do is also different. Now, this is the same members of the trusses, the same connection over there, basically the same geometry in this way. So this is 20 because this is 70, 20. I like working with this, preferable than the other one. But now we know F2, which is this one, 6 kilonewton, and we have two unknowns, the value of the force F1 and its direction. That's what we need to do here. So the way we're going to do this problem is exactly the same one. Remember, it's equilibrium. So summation of forces in and its particle equilibrium. Summation of forces in x equals 0. Summation of forces in y equals 0. I always say x and y, but you can rotate this axis as you see fit. The easiest way for now is working with x and y because we have that set of axes already predefined there. So we have a system of two equations with two unknowns. Our unknowns are F1 and the angle. So how are we going to do that? Summation of forces in x equals 0. Once again, this component, 5 cosine 30, negative. This component in x, 7 multiplied by 4/5, negative. This component, f2 cosine 20, positive. And this other component, f1 cosine theta, equal 0. We can reorganize this and we can say, I don't know, let's see, f2, but f2 I know it. Okay, this is 6. So I can solve for f1 cosine theta. I'm going to leave f1 cosine theta in one side, and I'm going to pass the rest, combine them here, and pass it with the opposite sign to the other side of the equation. So basically, let's do that. 5 cosine 30 minus 4/5 of 7 plus 6 cosine 20. And that's going to be negative 4.29 in this side, but remember I'm passing it to the other side, so it's going to be positive 4.292. And we have one equation that we can define an equation 1, if you will. Now we do the same thing for summation of forces in y. Summation of forces in y equals 0. And now we go with the other components. So we have this one, positive, points in the same direction of the positive y-axis. 5 sine because it's opposite the component that we are looking for. So it's going to be 5 sine 30. Let's go with this one. This is the component. It's going to be now the one that is parallel, 3 over 5 times 7. 3 over 5 times 7. However, it's pointing downward, which is the opposite of the positive, meaning will be negative. Let's go with this one. This component up, meaning positive. 6 sine, because it's at opposite to the angle. 6 sine 20. And this other component will be negative, first of all, because it's pointing downward. And it will be f1 sine of the angle equals 0. So I'm going to pass this to the other side and just reorganize the equation. So I will have f1 sine of the angle has to be equal to, and I'm going to totalize this, 5 sine 30 minus 3/5 of 7 plus 6 sine 20, and that's 0.3521 0.3521, which will make equation 2. Now we can solve this in any way that you want to this system. Obviously the solver for the calculator doesn't work for that. You can use substitution, solve for f1, put it in the other equation. I like when I have these type of situations, just divide one equation by the other one. So I'm going to divide equation 2 by equation 1, meaning I'm going to put here f1 sine of the angle equals 0.3521, and I'm going to divide term by term by the other equation, which is this one, f1 cosine of the angle and 4.292. Why do I do that? Because automatically these two cancel out, and then I have tangent of the angle equals 4.292, 0.082, which means the angle will be the inverse tangent of that answer, and that will be 4.69 degrees. And in order to get f1, I can substitute either in 2 or in 1. So I can say that f1 is going to be equal to 0.3521 divided by sine of the angle. That's equation 2. So f1 will be 0.3521 divided by the sine of 4.69, which means 0.3521 divided by the sine of the answer that I have here stored, and that will be 4.31 kilonewton, and that will be our solution. You see, these problems are really simple, and once again, the only difference between what we have been doing and now this is the word equilibrium, which means equal zero. Thank you for watching, guys. Let's work on the next video.